back. Remember, if these videos are helping you out, it's free to like and subscribe. It takes less than half a second and does help us out. Real quick shout out to X-Rocker. X-Rocker makes my chair here, and I actually had an issue with the chair, and the customer service was not only great in email, they also called me on the phone and they got me hooked up real quick to keep me rolling until I get a replacement part. They gave me something temporary to take troubles away, but they had excellent customer service, non-paid promotion. Absolutely would buy this chair again, would use the brand X-Rocker. Appreciate you guys. Welcome back to week 2 arrays. Today we are taking a look at the Caesar function. What we're going to do here is we're going to look at the specification, and we are going to, as usual, input those notes to our code so we can do a top-down code. So taking a look at what it needs, need to implement Caesar C, printf, main, value of 1. If it's an error, so we'll have a return value of 1. Usage Caesar key from main with a return value of 1 is an error there. We're using an argument k here. Now again, k could be anything. It could be kangaroo, it could be banana, it doesn't matter. K is just what they're asking us to call it, so we will go ahead and do that. And we're looking for non-negative values, and also it's asking us to loop through the alphabet. So basically if we go beyond the number 26, we just go past the end and go back to 1. So instead of using a -1 for B to become A, you would use 27 so that B becomes A. So it wants you to loop back through it, but it doesn't want you to use a negative value for that. We need to input a plain text. This is specific. We need to input a cipher text. That's specific. String, get string, etc. However, all they give you this week is this. So we're going to take all those specifications that we have here, and we're going to put those into notes, and then we are going to begin our code. So we went over all those specifications. What we want to do is put those here in a note value so that we can do a top-down. So the first thing that we're going to do here is check for the correct number of arguments. So we're going to use an argument count, which means we need studio lib h. So let's go ahead and include that. Include stdlib.h. And now we can use our argc, which is argument count. So if argc, and we need it to be 2. We need more than one input. So if it is not equal to 2, so we have to use it like that, right? So if argc, we are going to printf, and this is per the notes, usage dot slash Caesar key backslash n. So that's exactly what it wanted us to put in the notes. We're going to go ahead and use that here, and again, if it is an error, it asked us to return a value of 1. So we're going to go ahead and do that as well. Alright. Next thing we need to do is we actually have to include another library because we are going to be using string length and get string and things like that. So we need the string library. Include, and this time it's going to be string.h. And now we're going to make sure the key is a non-negative integer. So for that we're going to do a for loop here. So it's going to be a for if, so for integer I equal to 0, then I is less than the strlen of argv I++. Except it's not going to be fur, it's going to be for. So let's get that fixed, and let's go ahead and make a format adjustment here. And the next thing we need to do is return a value error if the input is not a digit. So we're going to use isDigit, which means we need another library yet again. We're going to add ctype h. So we've used isAlpha in the past. We're going to use isDigit. Now there is another way to do this. Technically you could go in there and do an if argv1i is greater than or equal to 0 and argv1i is less than or equal to 9. So, and then you could do a if character is a digit, else character is not a digit. You could do that. It's a little bit more complex code, so we're just going to go ahead and use the isDigit function. So let's go ahead and start our for loop here. We're going to get rid of that for now. And we are going to indent this. So if is digit arg v 1 I, then what are we going to do? Let's open that up. We need our error message, so let's get rid of that there. We need to exit with the status code as it said, right? So we need our printf, and it was usage dot Caesar key. And again, it asked us to return a value of 1, so we're going to go ahead and do that. Return 1. And we'll close that out. And let's close that for loop out. Now let's go ahead and move on here. We're going to convert the key from a string to an integer. We're going to use A to I, which is ASCII to integer. So we're going to take a string of ASCII and character and input it and return it as an integer, right? So let's see what that looks like here. So we are going to use int k as requested. Now again, k can be anything. They don't really go over this enough. You can, whatever you call k, as long as you call it that for the rest of the program, that's what it's going to be. But it asked us to use k, so we're going to use that. So we're going to use our A to I function here. argv 1. Close that out. And we need to get the plain text from the input, right? So let's get that text. So we're going to do string plain text. It's going to be equal to get string. The instructions went over that with us, right? And it's going to say exactly plain text colon space quote. Close that out and close that out. Next thing we're going to do is we're going to encrypt it using the input key that we are inputting into the terminal down there. So it's going to be printf. This is going to be the return, right? And then it's going to say ciphertext colon space end quote, and let's close that out. So the next one is we're going to loop through each character in the plain text string. We're going to start the character at 0. We're going to continue all the way through, so we're going to have like an I++, right? And the loop counter variable is going to be j, because we used I, we used k, so why not use j? We're going to initialize that to 0 and increment it by 1 after each iteration. All right, so let's get started on our for loop. For int j equal to 0. J is less than the string length of the plain text j++. Whoops, let's get that in there. Lowercase j ++. And let's open our for loop here. So now we need to do something that it was telling us in the text, where we need to keep uppercase, uppercase, and lowercase, lowercase. Right, so that's going to call for an if, else, if, and else. And it's also going to come with a little bit of math. So what I'm going to do here is I'm going to type out the code the way that I put it in, and then once I've typed the first line for the uppers, I'll go back and kind of explain it, because it's going to be the same for lowercase, and then if it's not a letter, it's just, we're not going to change it at all. So let's get our for loop open here. So we're going to go ahead and do the convert the uppers first, right? So let's move this down and tab it out. Our for loop is open, so if is upper in the plain text of j, then we are going to printf. Now we're going to use %c here, and we'll go over that in just a second, but we have already used %i, we've used %d. This time we're going to be using %c, and with a little bit of remembrance from some of the past videos, we should be able to delineate what that may be. So let's do plain text j, and we're going to do minus 65 plus K, and then percent sign 26 plus 65. And we'll close that out. Now percent %C is using a character, right? We had I for integer, and we're going to use percent %C for character. So even though it's in quotes, it's going to print the character in the plain text each time you go through it. Now let's talk about the math a little bit, right? So what does this line mean here? So we have plain text J, which is like the jth letter, so the first, second, third letter of the J input, so that we call it the jth letter in this case, of the plain text string, which is being encrypted, right? So then we subtract 65 because 65 is the ASCII table that we need, right? So that's the plain text character. Then what we're doing though is we're shifting the character code so that A has a value of 0, B has a value of 1, and so on all the way through the text. So then we can apply the cipher, including shifting the letters in the alphabet by the fixed amount, right? Now we add back K. So that adds the encryption key that's input into the terminal. So whatever number was input into the terminal for the cipher, that's where we're going to go ahead and do the shift position to the alphabet. The percent sign 26 actually takes the result of the previous step, and we calculate the remainder divided by 26. Now what that's doing is it's a 26-letter alphabet in this case, right? Again, other alphabets this might not work. But what that does is once we go through 26, we take the remainder of that and we begin back at 1 or 0, in this case A for alpha. So that's what's causing us to loop back through the A through Z, right? So after 26, whatever the remainder is, we're going to go ahead and keep going on that. Then we plus 65 to add back the shifted and wrapped character code. And the reason we do that is that that's the corresponding ASCII code for the encrypted letter. So this is how we're going to keep uppercase, uppercase, and lowercase, lowercase. And that percent sign 26 is really important because that's what's going to add the remainder and help loop us back through the A through Z. So that's what that's doing for is upper, and we're just going to do the same thing for is lower, right? So we've got our if, which means for our lower, we're going to go ahead and do our else if. So let's do that. Let's move that out and do our else if for the lowercase, right? And we're going to do the same thing, right? So except is lower this time, and a plain text J, right? Plain text J. Close that out there, and else if, so what are we going to do? We're going to have our printf function, same as above, printf, and then percent %C for the character of plain text in J. And this time, instead of the 65, because we're using the ASCII table, we're going to go ahead and use our 97 plus the cipher, right? So plus K, adding that back in there. And then the same math on the back end, percent 26 plus, in this case, 97. And let's close that out. And we're going to go up here and we're going to fix this little error here, just a formatting issue. So move that out. And we're also going to, since I missed it here, put that in there. Alright, so now we need the else. If it's not a letter, it needs to remain unchanged. So let's do our final else here. Else, pretty simple one here, just printf. And if it's not a letter, we just don't want to do anything to it. So we're just going to printf, whatever the character letter is, and of plain text J. So we're not doing any shifting on this. We're not ciphering that in any way. So that one's just going to remain the same. And we'll close that out. And we'll close that for loop here. And it also asked us to print a new line. So we're going to printf. And simply a new line here. And that will be it. So go ahead and go into Caesar now. Let's give it a test. Make Caesar. Looks like I put an O instead of a 0, so let's go ahead and fix that. Make Caesar. And after my last line, I forgot to put a semicolon. Let's do that. And try one more time. Alright, so /Caesar. this one's going to be a little bit different than the ones you've done in the past. You're actually going to put ./Caesar, then you're going to put your cipher. So we're going to try something really simple. We're just going to put 1, so shifting the letters by 1. Alright, so that code let me know I missed something here, and it's actually something that you probably wouldn't have known on. It's on my is digit, right? I forgot an exclamation point for it. Alright, so let's give that a shot now. So we're going to make Caesar, and then ./Caesar, and we'll do 1. Plain text, we just want ABC, and it should output BCD. So that looks good. So that little exclamation point there was really important. So let's go ahead and take a look at style now and make sure everything looks good here. %26, it wants fixed on that, and it looks like that's it. So right here I forgot a space. Let's go ahead and do that and check the style again. Looks good. Let's run our check. And you guys are all set. This is CS50. That was Caesar. I'm Devin. If you guys have any questions about what anything in this code does, drop them in the comments. I'll be happy to respond to them. Totally free for you guys to like and subscribe. Takes less than a second. Helps support me. Thanks for tuning in, guys, and I look forward to seeing you on the next one.